at the aspect of not water as a sector, but water as life.
Yes.
Where we try and integrate all aspects of climate change, all aspects of water scarcity, all aspects of water stress, and look at water as a whole, where you don't want to have silos of separation.
Absolutely.
You want to have a lot of cross-sectional talks.
Absolutely.
And one of the things that you have to do for any project to succeed is to start at the lowest level. You can always have trickle down from top, but the effectiveness of a project is most efficiently done if it comes from bottom up. The community has to get involved.
Absolutely.
And if you have the buy-in from the community, then you have the ability to execute projects that you won't believe that can be done, because you have the local community interested in it. You have to get them involved in it, because they are the stakeholders whose life is going to be changed.
Absolutely.
So if you want to look at the most impact that you will make with any project, it has to come from bottoms up. You have to have the community involved. You have to have the stakeholders involved. An example I will tell you is, we start looking at all the satellite data, right? We look at weather. We look at storms coming in. We look at hurricanes coming in. Now there's a lot of precise data that is being collected
already there. Absolutely.
But the critical aspect is that data has to filter down and come to the local area where the impact is going to be, and the people have to be informed well in advance so that they are prepared. Otherwise, all the data collection that you do is of no use if the people are not prepared.
Absolutely.
So this is the concept is called from satellites to sandbags.
Sandbags.
Yeah, sandbags. When there's a hurricane coming in, you want to have the locals trying to protect their property by putting sandbags around and putting dunes around and protecting water from coming in. But that information has to be relayed to them well in advance so that the sandbags can be in position before that.
Yes.
So satellites to sandbag is a project that the United Nations is also looking at, where you want to see that communication is there, information flows, and the people who are impacted are the ones who get the information at the right time so that they can prepare themselves.
That is why I said that in India also, now in the new education policy 2020, government has very specifically tried to make it compulsory that all kinds of teaching learning has to happen with the community handholding, in the community, with the NGOs. You have to connect and do the studies. All kinds of work is now converted to like an internship and project based learning. So that is very good happening today, and that's what we feel there is a lot of scope to learn by this means. So what you have said just now is really very, very relevant, and that is what is required. Like, for an example, Dr. Rajendra Singh says that crop pattern with the rain pattern, soil biodiversity with the crop pattern. So these all things like we have to understand and and when we have gone to the field, we found that those experienced people, those who are staying there, they may not be much educated, but they are so experienced that more than an engineer, that they are telling us what is the right kind of thing which can be done at the local level. So these also things we need to learn from them.
That is knowledge that is there.
Yes.
And if you ignore that knowledge, then you're doomed to
absolutely,
not
absolutely.
So
more than Google and our reference books and all, they provide us the handy solutions.
The local experience, the knowledge that the people have, that has to be brought in, and that's invaluable knowledge.
Absolutely.
So if you want to really succeed, like for example, you start looking at crops, right? What Dr. Rajendra Singh was saying about selecting the right crops for the right amount of soil and the water is very essential. If you look at a broader perspective world over, I would say that water stressed areas should grow grains that are not really water.
Like millets are propagated nowadays.
Like water thirsty. Rice, for example, is a very, very water thirsty product. So you need to grow rice where there's plenty of water, not in water stressed areas. So you need to look at it from that big global perspective of how you want to manage this. So it's the food water nexus.
Absolutely.
Start looking at food, water, and climate.
Because ultimately today we are talking about the water security. Tomorrow again, now already food security issues have started rising, because most of the agricultural lands are also being converted for some other kind of an infrastructure.
Well, you go back to civilization, you will find the civilization has grown along the rivers. That's because water was very essential for any growth.
Absolutely.
And if you ignore that, then you're going at your own peril. You can't really succeed if you don't have that concept of water being, and water in the United States we take water for granted. There are a lot of places in the world, including India, where water is a scarce commodity. People pay for water, and you still struggle for good quality water, and people don't understand that. You can throw stuff in the river, but before you throw stuff in the river, think twice about
one thing I saw here, the difference, like I was seeing the Harlem and the Hudson, and when I look at our India's rivers, here I saw, although there are in the catchment areas, there is lot of residential and other places which has been occupied. Like floodplains also I cannot see most of the places. But still the water bodies look to be clean. I don't know, after we do the monitoring sampling of the water, what will actual status now, today's day. But still I find it more clean. So what may be the practices, or what do you feel that it is?
No, it's multiple. The Hudson, for example, if you start looking at the Hudson is at the cleanest in the last 100 years. The Hudson was a very polluted river.
Okay.
Not because of people pollution, because of industrial pollution. Because upstate New York had a lot of industrial applications, industrial plants. GE had a plant there, IBM had a plant there. And at the earlier days, they used to dump things into the river without knowing what the consequences are. And as science progressed and we realized that that's bad, so spent a lot of time and effort and money to clean up the Hudson. So the Hudson today is in a very, very good shape compared to what it was even 50 years ago because of the efforts that we have put in.
But I think yesterday I was talking to Dr. Neil that when the city plans are being designed, from that time onwards, like suppose I took a look at now New York, because as per I think about Brooklyn we were saying that the water bodies are much more clear than the New York, which place we were talking about yesterday?
Well, the harbor, in New York Harbor?
Maybe.
Project,
like,
take to the building project
yeah, whereas here it is not that clean and other places, because mainly he was talking about there is a difference that here drainage and the storm water channels, they are same. But in other places it is now separated.
In older, larger cities,
combined,
it's called combined sewer systems,
where
you have rainwater and sewage going into the single pipe. Okay. And that is how the older cities were designed. If you go to Los Angeles, if you go to Chicago, if you go to New York, if you go to any large city, if you go, typically earlier infrastructure was all a single pipe that was taken, DC water, for example. But they're trying to see whether we can separate it out, but it's a very expensive process. Separating out, putting storm sewers alone is a very expensive process, and it takes a lot of time and money. So wherever there's new construction going on, or where there is, for example, in the New York area, if you go into Long Island, Nassau and Suffolk counties, they didn't have sewers. They had septic tanks. Now they're starting to put in sewers. They're planning to do separate sewers. Okay. There's a portion of Eastern Queens where there's separate sewers. There's a portion of Staten Island where there's separate sewers. Wherever the opportunity is there, you can put in separate sewers, you put it in. Otherwise, with a combined sewer system, CSOs are what we are handling. CSOs are, and
what is that CSO?
It's combined sewer overflow.
Okay.
Because it's a single pipe that carries sewage and rainwater. Okay. When it starts raining,
overflowing.
The capacity of the plant is met, and beyond that the plant cannot take in. So that gets diverted, and that gets diverted into the receiving water, into the river. So that's called an overflow, and it's a combined sewer overflow because it's coming from the same pipe. So one of the challenges that we are facing now is try and mitigate combined sewer overflows, try and reduce combined sewer overflows, and try and see what best we can do to minimize the impact of combined sewer overflows. And that gets now more, it's becoming more and more real because of the extreme weather events. When it rains very heavy, short duration, high intensity rains, your systems will get overwhelmed, and so there's going to be a problem.
But 20 something years ago, was it like 20 years ago? When we had the CSO events, whenever it rained a lot, Chris, we had a project. Chris said, Neil, it's raining, we're going to collect some samples, and we go in a boat, we take a boat, and we measure, the efficiency of the process is all the sewage set into the bottom, the solid set into the bottom, the recovery. So we used to do like a depth sampling to see the stratification.
And we were actually, we have tried, you have to give credit to New York City. New York City has tried a lot of novel methods to try. Okay. What we had done there was we had tried to capture the rainwater in the bay by putting in curtains in the bay and having floating pontoons on top. And what we used to go do was to measure the conductivity and the solids. As they said, because what happens is there's going to be stratification, right? Clean water, salt water will be below, clean water will come on top. So you can actually, the idea then was to store the rainwater on top and then pump it back. But then the impact of low tide, impact of high tide, all of that had to be considered. So it was a complex issue that we looked at.
Here in India, what now they have started in the policy matters, as I was telling, interventions. Now they are making compulsory wherever the buildings with more than 100 houses. So they are making it compulsory that at source itself, within the building itself, all garbage and the drainage treatment has to be there. So that is what is made compulsory. But here now, just I wanted to know from you, like in STPs which are being installed, we have found they are not much useful in India as such, and the way the treated tertiary water which is getting created, and then that is again discharged in the same polluted rivers instead of reusing that water. And mostly we see that whatever the tertiary water also is coming out of the plants, they are not of good standard, almost of that dirty kind of quality only it comes out. So what are we doing here in terms of STPs? Can you just tell?
No, see, if you want to look at New York City, New York City has 14 wastewater treatment plants. And these treatment plants have grown with the city. They are not new plants. They have been built from the 1930s onwards, depending on, as the city expanded and depending on the needs. The first plant that the city built was in Coney Island. And if you go to the Coney Island plant, you will see that it is right on the beach. And that was built because there was water pollution there and people were getting sick from cholera and typhoid and things like that. So they started they put their first treatment plant there. And then as the city grew, there are different plants put in. Now what happens here is that when you have these plants and they bring in the wastewater into the plant, it goes through a series of treatments. And then it gets discharged into the river. And each plant has got a specific permit. They have to meet that permit limit. If they don't, they get fined. So it's a regulatory authority, a regulatory framework under which they are working. So you have to have your treatment efficiency up to the point where you can discharge the water into the river and it meets the water quality standards. So you're starting to look at, what you're discharging has to meet the water quality standards of that river. Now, if the river is polluted, then of course your water is purer than that. But the challenge here is to make sure that you don't discharge dirty water.
Monitoring is most important.
And anything, anywhere in the world, people will work if there is a regulatory authority that binds you for doing something.
And
even
strict action
we did
of
a lot
that,
of things because we were mandated to do it. Otherwise, we would be fined. Otherwise, we would be penalized. So that becomes a very important aspect of this whole paradigm of treatment, where you need to have a regulatory authority which can enforce laws. You could have the best, India could have the best laws that you can have for water pollution and prevention, but if it's not enforced, then
enforcement is the issue. Now, as I called you as a waterman of the country, as we were putting it, now I just want to know about this biological nutrient removal which you were saying, and how are you trying to give the strategy of this? This is very novel for me, so that if you can explain about it.
Biological nutrient removal, see, our treatment is all biological, right? We use microbes to remove, even our secondary treatment, when we do treatment, is use of microbes. So the microbes use the soluble, see, the way the treatment is done is, once the water comes into the treatment plant, there is a primary treatment section where the heavier solids settle down, and then the soluble organics come into the aeration tank, where you have the microbes. Now you give the food to the microbes and you give them oxygen so they can breathe and they can eat. And so in the process they'll remove the soluble pollutants out of the water, and then you can settle out these bugs and then take them out of the system or circulate them for your purpose. Now these are bugs that are called that use carbon as an energy source. They're called heterotrophs. They grow in abundance in any environment. But there are other bugs also, other microbes also, that if given the right conditions, they don't need carbon as an organic carbon source, energy source. They can use nitrogen as a source. So you have to create the right conditions within your treatment system to have those bugs also survive and make them do the job that you want to do. And that's essentially what we did in New York City. New York City had traditional biological treatment systems where we created zones within those aeration tanks where we had what are called anoxic zones and oxic zones, and we cultured a new set of bacteria which can then remove nitrogen for you. So nitrogen removal nitrogen is a multiple step process. Nitrification, where ammonia comes in. Ammonia is the most predominant, organic nitrogen, ammonia is the most predominant form of nitrogen that comes into the plant. You oxidize it from ammonia to nitrate and nitrate, and then you reduce it from nitrate to nitrous oxide to nitric oxide to nitrogen gas and take it out into the atmosphere. So that is a process of nitrogen removal. Phosphorus removal is also can be done biologically. It's called enhanced biological phosphorus removal. Or a lot of places they do chemical precipitation of phosphorus. So you could add, say, ferric, or you could add alum, and then you can remove phosphorus out as a sludge. But we prefer not to add chemicals into the system. We try to do it biologically. So phosphorus removal, phosphorus is a nuisance. You know, in our area right now, phosphorus is not a big issue. Primarily because about 30 years ago, the Soap and Detergent Association of America decided that they will reduce the amount of phosphates that they use in detergents.
Oh wow, this is very good.
So the phosphate use in detergents reduced, and because of that, the phosphate coming into the wastewater reduced. So our phosphate limits are now what used to be at 10 and 20 milligrams per liter are now in 3 and 4 milligrams per liter. So right now, as we speak today, phosphate is not a big issue for the water bodies around here. But around the country, phosphate is still an issue. Even 3 to 4 could be a problem because, again, phosphorus and nitrogen are nutrients. They promote life, and they have problems of conditions of hypoxia can be created in water bodies, especially during summer times where the temperature goes up, water temperature goes up. Dissolved oxygen levels can drop because of these algae that will grow because of the nutrients that are pumped into these water bodies. So both nitrogen and phosphorus we try and remove. Whatever phosphorus, and the other aspect of phosphorus that comes in is we treat the water. See, the sewage comes into the treatment plant in the single stream, right? We settle out solids, and then we do the aeration tank, we do the microorganisms work, we settle the microorganisms because it's a biological thing. You give them food, you give them air, they eat the food and they grow. And you don't need as much of those bugs as they grow. So you settle some of that and waste it. Now the sludge that is settled down, that has to be removed from the plant also. So you come in with a single stream, but you split into 2 streams in the treatment plant. One is the liquid stream, the other is the solid stream. Now the solid stream is a slurry. It's still a lot of water in it. So you need to handle that and treat it before you can dispose it off.
But what do you do about the salt rejection in that? In most of the places, salt rejection is a big issue in every kind of a treatment.
When you say salt rejection, what exactly are you?
See, even in case of effluent treatment plants and even in case of STPs, a lot of in the process there is a lot of salt also. Like now today there is ingression of coastal water is also there.
If there is saline water coming in, then that's a different issue.
That kills the process.
Yeah, that kills the process. In fact,
yeah.
right now I'm working on a plant in Long Island, the Bergen Point plant in Long Island, where one of the issues is this: their settleability, solid settleability has decreased tremendously because of saltwater infusion.
Yeah.
Because they're right at the ocean, and there's infiltration of salt water that comes in.
Yeah.
And so what happens is that once saline water comes in, then the biological process gets disturbed, gets upset. So that then it becomes a challenge. But that apart, when you have these solids, which is again full of nutrients, there is a lot of because you're talking about living creatures, you're talking about microbes. They are bodies like ours. They contain carbon, they contain phosphorus, they contain nitrogen. So what we do is we settle it out, and then in the earlier days, we used to take it, dump it into the ocean. But the federal government turned around and said you cannot do it anymore. So then we built what are called dewatering plants. Inside our treatment plants, we built dewatering centers where we could dewater and make the slurry more solid and remove the liquid out of it. And then treat the liquid before you can send it out. What happens in the process is, I don't have a process diagram here.
For the water run?
For the entire, and dewatering, what we do is we put it into a digester. Digester is nothing very similar to our human stomach. It's the same temperature, about 97 degrees Fahrenheit.
It's a biological digester only.
Yeah, it's a biological. You bring in the bugs, you put it into the digester, you keep it there for 15 days, and you essentially cook it. And at the end of that, you remove it, you dewater it, and essentially what you're trying to do is you're trying to kill the pathogens. You're trying to kill the disease-causing bacteria in that process, and then remove it.
And recover some methane gas.
Yeah, recover the process. Because you're breaking down organic material, there's a lot of lysis going on. So there's multiple steps where you can. There are multiple groups of bacteria that do work, and eventually there is the methanogens who actually consume this, and they create methane and carbon dioxide. And the methane is the gas that comes out of these, and you can use the methane. Now, if you look at the totem pole of energy and activity, methane is at the lowest end of the totem pole. There are other things that you can extract.
Yeah.
If you can control the process, that's one of the things that we are doing right now. The process of digestion itself is multiple steps. The first step is hydrolysis. After that is fermentation. If you can control that process of fermentation, you can actually extract volatile fatty acids, VFAs, which can prove to be more value added than just methane gas. And that's one of the things that we are trying to do now in the city. We are trying to, because the city uses a lot of external organic carbon for denitrification.
Yeah.
I don't want to go into the details of nitrification and denitrification because one is done by autotrophs, the other is done by heterotrophs. But historically, the wastewater that comes into New York City plants are weak in terms of BOD. So if you want to do any later tertiary treatment, you need an external carbon source, and the city spends a lot of money into that external carbon source. So now we are trying to see whether whether we can extract carbon out of this process and use that instead of buying external carbon. So that's
use methanol, right? What do you use?
Yeah,
Methanol.
we use glycerol right now.
Glycerol.
Yes, we are using methanol, then we use glycerol. Now, instead of glycerol, can we use these volatile fatty acids, which are butyrate and acetate and propionic acid and all of that combination, whether we can use it as an organic
In
compound.
terms of source, one second. In terms of source, I was at a place in India, in Ahmedabad. They're looking at making biodiesel, and one of the wastes is glycerol. So if it can be used as a good source, I told them about wastewater treatment is used for denitrification processes.
Yeah, you can. Out of all of this sugar mills, for example, you get the molasses that comes out.
Yeah.
Can be used as an energy source.
Now, waste as energy, that is a concept which is going on very much. But my last question now. We are also recently started doing a very simple way of cleaning the water bodies is by the help of bioenzymes, which we are making from the fruit peels. Jaggery, water and fruit peel. Just a fermentation process, and after that whatever the extract which is getting produced, that we are diluting and we are spraying it on the water bodies, and it's giving a very nice kind of a result. So do you have any idea about that, or what do you feel about that?
No, I don't know what kind of water body you're using it, what is the volume of water that you treat?
That is lakes, big size lakes,
okay.
Even more than 4 acres of lakes. That is what we have started, and that is showing very good results.
Yeah, you can have decentralized treatment options.
That is how we are
different
trying.
kinds and different methods can be used. There's no one magic bullet to treat this process and to alleviate the problem. So depending on what your local needs are, you have to adapt to the local needs. And that's why, many times the treatment processes that we do here might not be applicable directly to some other environment, some other country. So you'll have to adapt.
Yes.
And adaptation is the most critical thing.
That's what I said, that we have to.
Technology is there, but you have to adapt it, and you have to use some common sense to get to where you want to go. So that's the
Thank you very much. I got a lot of things from you. Thank you so much.
Looked at this convenience of plastic bags that we were using here in the West, and they started adopting it, and it became a major
At
problem.
Governor Eco Village, where Dr. Donley's affiliated, they have pyrolysis plant. Take the plastic bags, make it into fuel.
Yeah.
So that's, I mean, but the thing is how
To prevent regrowth in the pipes when it enters the city. But otherwise, we spend a lot of time and effort in upstate New York, where a watershed is, to protect our watershed. We keep the watershed clean.
Very good.
We make sure that there's no pollution in the watershed. So the water travels through tunnels 100 miles away.
You know, Anna Kaplan, they live there. You know, right at, we went to, they live in, they had Alex, remember Alex, right?
Yeah.
He had a house right there.
Okay.
And it's no development could take
No
place
development,
there.
yeah.
The city bought all the
Very
land
good,
there.
very
City has
good,
got a
very
lot of
good.
land there.
Yeah,
So that
nothing,
there's
yeah.
no development and they protect the watershed. So the watershed is protected, the water comes into a reservoir, from the reservoir
There's a police, there's a DP police there
Yeah,
parked
yeah.
there. You can't, nobody can do anything there.
Oh, very
and
good.
it comes into the reservoir, from there it comes through tunnels which are 100 years old and 100 miles plus long, and then they come into the city and everything is flows by gravity.
Oh,
And
wow.
once it comes to the city, then of course it gets
Very good.
distributed. So
So untreated water they drink.
yes,
Oh,
yeah, literally no treatment because we spend a lot of money to keep the water pure.
Okay,
But in
very
the,
good. In the natural way only.
Yeah,
but the one from, there's two reservoirs. One is Croton Reservoir, which is much lower quality water than Catskills, Delaware.
Catskill, Delaware,
Yeah,
and
it's
Croton
much
are
higher
three
quality.
water sources. Croton is the oldest one.
Yeah.
And one of the issues with the Croton was that since it was old, the turbidity in the water was very high. Soil sediment content was very
Sediment.
high. So that 10% of water has now to be treated before it comes into the
This
city.
is a watershed
The
in
90%.
Catskills.
Yeah.
Next, that's where we got our water from, the Catskills, Delaware. I mean, that's Anna's house is right there. So
Yeah.
they got yeah.
Yeah, so-
but there's no development there at all.
Very good.
Nothing can be
So
developed.
that's one of the things that
Very nice.